Eisenmann, the world's leader in environmental technology, introduces you to the Vrto-C, the industry's most reliable VOC abatement system. Throughout the next few minutes, we'll demonstrate the technology, installation, and maintenance benefits of the new compact Vrto system, otherwise called the Vrto-C. Around 1990, after studying substantial inefficiencies found with conventional regenerative thermal oxidizers, or RTOs as they are commonly called, Eisenmann developed the first valveless RTO. This technology soon proved to offer substantial performance advantages as well as economic benefits over the conventional design. To better illustrate this technology, let's compare the differences between a conventional RTO and a VRTO. For years, thermal treatment of process had been the primary means for controlling VOC emissions. In the 1970s, RTOs were developed using a dynamic heat transfer process. This conventional RTO technology consists of multiple chambers and valves. With a conventional design, there are at least 3 vessels required: the inlet, the outlet, and the purge vessel. As the system operates, the airflow is redirected with complex valving so that the inlet will become the purge vessel. The outlet will become the inlet, and the purge becomes the outlet. Contaminated air enters the first chamber and moves up through a ceramic bed, while the air is preheated to near the required combustion chamber temperature. A burner provides additional heat to maintain the oxidation temperature. The air is then exhausted through a separate vessel, where heat is deposited into a heat exchanger bed, so that vessel can become the preheat vessel. When the airflow is redirected by valving, a third vessel sits in a purge mode. After that vessel is properly purged, it becomes an outlet vessel. Redirection of air from vessel to vessel is accomplished with valves that are continuously being driven open and closed by hydraulic or pneumatic actuators up to 30 times per hour or over 250,000 times a year. Airflow is actually stopped when the valves redirect flow into a different vessel. This causes abrupt pressure swings that can cause severe problems to upstream manufacturing processes. The overall destruction efficiency of the system depends on how well the valves seal. It is very common for the actuators to create torque of over 25,000 inch-pounds to close the valves. Because dirt and particulate can build up, they must over-torque the valve to secure tight sealing. However, deflection of the blade occurs over time, and performance of the system diminishes. Two-can systems with poppet valves face similar problems as the conventional design, creating valve deflection and deteriorated performance over time. However, poppet systems cannot achieve high destruction efficiencies even when the system is new, because the system has no purge. After one can is acting as an inlet, it will become an outlet before being purged. Any VOC that is trapped in the can will be emitted to the stack when it becomes an outlet. Two-can poppet systems also have abrupt pressure swings because prior to reversing, the flow is stopped for a short period of time, similar to the conventional RTO. In comparison, VRTO technology completely eliminates the need for multiple chambers and has no valves with metal-to-metal wear points, slamming open and closed 250,000 times per year. The VRTO has a reduced footprint because it's more efficiently designed. To begin, the process exhaust stream is collected and directed through the VRTO vessel by a variable speed fan. The VRTO's single moving device, the patented rotary distributor, controls airflow through the inlet, purge, and outlet section of the heat exchanger. This design eliminates the need for frequent adjustments or replacement of costly valves required with conventional RTOs. The exhaust stream is then directed up through the inlet wedge of the rotary distributor and corresponding heat exchanger sections. The airflow is preheated to near combustion chamber temperature as it travels upward. The process exhaust is oxidized in the combustion chamber. A modulating burner provides additional heat, if required, to maintain oxidation temperature. The exhaust or outlet wedge of the rotary distributor allows clean, oxidized air to flow downward through the exchanger, where the exchanger media is preheated for the next cycle of incoming process exhaust. Clean air then exits the VRTO vessel and is released to the atmosphere through the stack. The purge wedge of the rotary distributor follows in rotation behind the inlet wedge, continually flushing the exchanger media with clean oxidized air to maintain constant high destruction efficiency of over 99%. The most important improvement that the VRTO offers over conventional RTOs is that it has only one moving part that has no wear points. Therefore, a 99+% destruction efficiency will be continuously achieved over the life of the system. Because the VRTO uses a rotary distributor rather than valves to direct airflow through the system, it can maintain a near constant pressure differential at the inlet to the system of less than 0.25 inches. Conventional systems experience pressure fluctuations of at least twice that of a VRTO because conventional systems are actually stopping flow momentarily as the valves switch. With fewer moving parts, maintenance costs are also substantially less for the VRTO. Valve replacement is not an issue. The system is valveless. A single rotary distributor with a small motor replaces large valves and messy hydraulics. No frozen pneumatic lines in the winter or viscosity problems with hydraulic lines. Skid mounting allows for shop assembly of the system at Eisenmann's own fabrication facility. A controlled environment located at the U.S. corporate headquarters in suburban Chicago, and because it is pre-wired and pre-tested, the VRTO-C can be installed quickly. Installed within a week, the VRTO-C requires only 2 utilities, gas and electric. This unit offers the smallest footprint available per CFM of gas treated. Valuable plant real estate can be used for production expansion rather than abatement needs. Delivery from Eisenmann's fabrication facility takes place on 2 trailers, one for the skid-mounted base section and one for the middle and top section of the VRTO-C. Since the base is skid-mounted, it's easily removed from the trailer in one piece and placed on a concrete pad utilizing a single crane. Once the skid is set into place, the middle section of the VRTO can be set. This design can accommodate a variety of heat exchange media. The top section, which is the combustion chamber, is set last. The next step is seal welding of the 3 sections. This eliminates fugitive emission problems common in bolt-up construction. Maintaining the VRTO-C consists of working with components that are common to all plant maintenance personnel. Periodic greasing of fan bearings, drivetrain, and the rotor bearing area are all that's necessary. 50 man-hours is all that's needed to maintain the system for a year. The VRTO-C comes in standard sizes up to 60,000 SCFM. On flow rates greater than 60,000 SCFM, or as your abatement needs increase, multiple vessels can be easily installed. Since its introduction in 1990, Eisenmann VRTO technology has been the choice for many companies that lead their particular industry. Eisenmann has nearly 300 units installed worldwide, and our installation list is published. This gives you the opportunity to talk to our customers directly about their experience with Eisenmann. Every Eisenmann system is delivered with a 100% uptime guarantee and 24/7, 365 response service guarantee. Eisenmann does not walk away after the system is installed. We strive to make you a loyal customer by adding value beyond startup. Only Eisenmann maintains its own ISO 9001 certified fabrication facility at the same location as its engineering offices in northwest suburban Chicago. With design and fabrication under one roof, it's easy to understand the quality and scheduling advantages Eisenmann can offer.